different ways. You really need to find the right strategy for yourself. But now we talk about online and offline systems. Really the key and the biggest challenge here is the data movement. If you're building large number of insights, the question becomes, how do you move large amounts of data through networks and through multiple data centers? The data transfers can be very expensive, and the techniques that we use to move the data around are not very flexible. For example, ETL process is a very manual process. So I'm going to walk you through, this is one of the last slides. I'm going to walk you through the data movement optimization evolution that we had. The initial state of the data movement was when we didn't do any optimization. This is just to get a baseline. We were transferring about 500 gigabytes of data in 16 hours from one network to another network. Then we did optimization. The key in the optimization was, how do I minimize the number of bits that are moving across the network? So you can minimize the bits by compressing your data, selecting the right data format, make sure the data format is not too verbose, even doing validations before moving the data. Am I moving the right data? Because you don't want to find on a live system, oh, I'm getting null values and so forth. So the key is optimize your data format, do all the validations you can do upfront before moving the data, and use the compression. Some people shy away from compression thinking it's going to slow down my system. These days compute power is so efficient that compression doesn't really slow down that much. So by doing this level of optimization, we were able to move 2 terabytes of data instead of 500 gigabytes in 16 hours. But the need is to move 10 terabytes of data in 6 hours. So what was holding us back in phase 1 was that the online data stores are not really optimized for parallel data loads or bulk data loads. They're more optimized for speed, quick lookups. So that's where we started having putting together a strategy, two-tier strategy, that you do offline data movement at full speed to a NoSQL persistent backing data store. And on top of that, you have in-memory data store, your cache, to which your applications are interacting with. So your applications can always be reading or writing data from in-memory data store and never feel or are never competing with the full speed bulk load that's happening on a NoSQL database. And you can lazily load data into cache, different strategies that you can apply. You can have a batch process. As soon as the data comes into NoSQL data store, you can push it into your cache. The idea is to separate the data store that your online applications are accessing from the data store that you use to move the data into. Okay. Very quickly, I won't go into details of next use case, but the thing is the power of Hadoop type of systems or combining online and offline computations really help you build very complex decisioning capabilities. Here I'm giving an example of graph-based decisioning. You can build social graphs because building social graphs is very time-consuming or very computation-intensive. So you can build them offline, bring them to online, and when you bring into online data store, as events are flowing into your system, you do incremental updates. Means if your graph was updated last midnight, then you apply all the events that happened since midnight till now to bring graph up to date. At the same time, you could be also computing aggregations around your graph at that point. And your reader applications can access this data really fast. Okay, so what do we get out of this whole talk, or what was the conclusion of this whole talk? That Hadoop is Hadoop type of technologies. They are best at processing variety and volumes of data, but they are not for real-time processing. For real-time, you really need CEP solution. That's where you can address your velocity. So both technologies complement each other. A lot of times there's talks if they're competing with each other. The fact is that they're complementing. So the key is that combine offline and online data, but to do that, your data integration is the biggest challenge, needs a lot of optimization. The challenge comes from our online data stores are not tuned for heavy loads, heavy write loads or bulk loads. So what we have seen that you could solve complex problems using offline and online systems, just like what we saw in our graph example.